Hello, my name is Brad Hayes. Today I would like to address the topic of wastewater disposal in the maturing Montney Clay Fairway of northeastern British Columbia. As background to my talk, I'd like to tell you that the BC Hydraulic Fracturing Review Panel in 2019 stated that safe disposal of fluids arising from hydraulic fracturing operations, particularly in the Montney, requires systematic research to better ensure regulations are adequate and that the risk factors associated with the procedures are properly addressed. Geoscience BC, a not-for-profit research organization, defined a project to address these concerns and provided funding to the PRCL team to undertake the study and to report back on the concerns of the Scientific Hydraulic Fracturing Review Panel. Currently, the BC Oil and Gas Commission authorizes subsurface disposal and regulates all reservoir and operating conditions in British Columbia. As the Montney has been developed over the last 10 plus years, disposal of frac flowback and produced fluids has increased substantially, and new disposal wells have been brought on stream to help handle that load. That being said, operators have been successful in minimizing disposal volumes using recycling and water sharing plans. But even with those efforts, some disposal wells have been filled to capacity, and there are concerns about the overall capacity of the disposal aquifers during Montney development for LNG in the future. The PRCL team is midway in executing this project. So many of the things I'll show you today are simply things that we're in the midst of data collection and the early stages of a compilation. Other things we've completed more substantially. So the team work plan includes a number of factors, including consulting with operators in the OGC to gain the local knowledge, particularly from the operators. Many of the details about individual disposal wells are in their hands, and they can tell us many things, have told us many things about specific wells that we weren't able to learn from the online databases or just going to Geoscout or AccuMap, things like that. So that consultation process is very important. We are looking from the reservoir engineering point of view to interpret the performance of existing disposal wells to better understand what they might do in the future and what other wells of similar nature might do. We've taken a little side excursion into reviewing existing water floods and depleted pools to understand whether they offer accelerated or better capacity for water disposal. The main body of our project has included characterizing and mapping regional disposal aquifers and fluids, and I'll show you an example of that. Mapping structural elements to identify discontinuities that will affect containment and compartmentalization of potential aquifers, as well the geomechanical stresses in the system. We put all this together and we'll be developing a set of conclusions and recommendations around safe disposal of waters in the Montney Clay Fairway. Here's a map overviewing the project area in northeastern BC. So you can see the BC-Alberta border right here along the eastern side of the map. The blue line outlines the Clay Fairway. You can see that we've got, or at least you can take my word, that we've got 176 disposal wells identified in British Columbia, a few more in Alberta in this little extra area that we've added, because there's some important information on the Alberta side. It helps us complete our reservoir characterization mapping, and there's also disposal well data, particularly in the Peace River Formation in the north of Elmworth area in here. So we've incorporated that information as well. You'll see that looking at the color coding, that most of the disposal wells in the southern part of the Montney Clay Fairway are colored blue, indicating that they are Cretaceous age aquifers. Moving to further to the north, we see more green Triassic reservoirs, and in the northwest and along the western margin, Mississippi and DeBolt Formation disposal zones. A few of these disposal zones, particularly along the west, are associated with fracturing, natural fracturing in the foothills. Most of the disposal that's happening now are in these thick, high capacity Cretaceous fairways in the middle of the Montney development area. Unfortunately, as we move northward, in general terms, the Cretaceous reservoirs shale out and are not available in the northern half or third of the Montney Play Fairway area. Looking at the stratigraphy in northeastern British Columbia, here's a standard stratigraphic column all the way down to the base of the X-Shaw here, and I've just kind of separated the two stacks so for easier viewing of the names. Any disposal zone that we look at in northeastern BC must lie below the base of usable groundwater, which is defined as about below 600 meters and or below the base of the fish scales marker zone, which I've indicated here in the red color in the middle of the Shaftesbury. So we're looking at aquifers, the youngest one being the Peace River Formation, Blue Sky Cadomin, all in the Cretaceous, Nikanassan, that's kind of earliest Cretaceous, latest Jurassic, and then in the Triassic, the Baldonal and Halfray reservoirs, the Permian Beloy, and the Mississippian DeBolt. Our focus will be on the upper 6 aquifers. We observed that through the area that the highest reservoir quality, best aquifer capacity generally lies within the Cretaceous and Triassic units. There are some very substantial DeBolt disposal wells, but they're much more difficult to assess in terms of characteristics and capacity. To start off the project, we undertook, as I said before, some extensive consultation with up to 20 existing operators, both oil and gas operators and disposal well operators. And many companies, the producers anyway, do manage their own disposal. And disposal is expensive, so recycling and sharing is generally preferred, and many of the main producers in the area have banded together to share their water handling plans to minimize the amount of disposal that's necessary. In undertaking their operations, several operators have observed that they've got limited disposal zone capacity and have had to abandon some wells and move on to others. Induced seismicity associated with disposal is a concern, but hasn't actually happened to most operators. There have been some particular examples that have been and are being investigated, but they've been very local, as operators are generally quite careful to observe the regulations in place. Fluid compatibility between the subsurface mineralization and fluids and the waters being injected can be an issue in some places. Some operators are working to address that very directly, both with their balancing their compositions at the surface and treating the reservoir downhole. Wellbore integrity is a concern across the board, as it should be with various operators. They generally do not consider the use of older wellbores to re-enter and use for disposal. Much of the mapping and characterization that we do that involves older wellbores points to areas where people can drill new wells purpose-fit for disposal. That being said, there are some uphole recompletions for disposal if wellbore integrity concerns can be addressed. One thing we did find out in our consultation is that there has been some disagreement with the regulator on the use of reservoir pressure limits, particularly when injecting into aquifers that were originally gas reservoirs that are relatively under pressure. So there's some questions to be answered there. Moving on to look at the structure of the area, Mark Cooper on our team has put together this composite structure map of the Montney study area, again outlined in black here. You can see that there are a lot of things going on, main features such as the deformed belt to the west, the Hay River shear zone, which is mapped from the northeast through the southwest and can be extrapolated southwestward towards the mountain front, where it actually gives us a significant deflection in some of the outcrop patterns. The well-known Fort St. John Graben, the Hudson Hope Low, and various structural features within the Peace River block that have been mapped out, at least in general terms. They're very, very sharp discontinuities in the subsurface, and some of these can have significant effects on the continuity of aquifers, and perhaps even near faults impose risks for containment of fluids in the subsurface aquifers, which is one reason we need to understand structure very well. The compilation of this information was conducted by Mark Cooper. He's going to be working with our geomechanical and reservoir engineering people to help understand the influence of structure on on reservoir behavior and compartments and geomechanical properties. In terms of the geological mapping through the area, here's a map of the Cadomin aquifer. This is a gross isopac map. One can see that the northern limit is formed by the Fox Creek Escarpment, which we can trace from west central Alberta all the way up through northeastern BC until we basically run out of the Cadomin Formation to the northwest of this map area. You can see a marked reservoir thick, up to almost 100 meters thick in the Cadomin here, associated with one of the alluvial fan epicenters along the original Columbian origin over here. This mapping is based on a number of previous studies by Petrel Robertson, plus some new work to fill in the gaps, and we've got the information of literally thousands of wells to help us build these maps. Superimposed on this Cadomin map are wells that are injectors into, or water disposal wells into the Cadomin, color-coded and bubbled according to the size of injection. Just let you know the legend is a little bit out of proportion here. So really we do have some very large injectors here, but the bubbles aren't quite as big as the bubble shows on the legend. Now I'm showing you just the Cadomin map here. It's one we've got ready for this presentation. We do have regional mapping in progress for the major aquifers ranging from the Peace River down through the halfway. And each will be characterized with a gross isopac map, a net porous reservoir maps using different porosity cutoffs where necessary, depth of formation top, and then an analysis of reservoir fluids and pressure systems associated with those aquifers. The geomechanical analysis work being done in our project is being done by Pat McClellan, and he lays out the goals of his work is to characterize relevant in situ stresses and reservoir pressures where data are available. And so he's talked a little bit here about gathering and putting together that data. Particularly important are DFITs, or diagnostic fracture injection tests, which help us understand the reservoir fracturing and closure pressures that are key to understanding geomechanical properties. And so some amount of geomechanical work has been done to date, as Pat has laid out here. And just to detail that a little bit, he found 23 disposal wells that had records in the files that actually said they had DFIT tests run. When these were reviewed in detail, it found that many of them weren't full DFIT tests that included fracture closure pressure determinations, so they were more just injection fall-off tests, providing some useful information, but definitely not all that we needed. It's very apparent that, you know, we know there's a lot of testing in this journal area, but almost all the DFIT tests that we find are in the Montney Formation, as operators are investigating how best to conduct their hydraulic fracturing operations within the Montney itself. There's really relatively little data that's within the disposal aquifers that can aid us in understanding their characteristics. Nevertheless, we found 10 wells with good quality data, investigated across 6 major reservoir zones. And the work is in progress right now to update and refine our knowledge of these units. Regional work shows that horizontal stress orientations, it should be no surprise to anyone here, primarily oriented northeast southwest, and there's a bunch of tadpoles plotted up here from the Geological Atlas of the Western Canada Sedimentary Basin and the World Stress Map. SMAX data have been compiled mainly from borehole breakouts, but we've got stress orientation methods, measures using other methods as well. Now, unfortunately, we didn't get the study area properly labeled on here, but over in the eastern part of the map sheet here, east of the foothills front, where we've got all these breakout patterns, the Kisma area, Kiskatnaw area, where a lot of the Montney hydraulic fracturing is taking place, work has been done from induced seismicity data sets to understand stresses better. Now, there's a great deal of overlap in our work in this particular area with some of the other research projects going on in northeastern BC that are focused on better understanding induced seismicity issues associated with my Montney hydraulic fracturing. So we've got some collaboration going on between the various Geoscience BC projects in the area. Looking at the reservoir engineering analysis component of our study, a primary goal is to compare injectivity and reservoir storage capacity, and in particular to compare horizontal and vertical disposal wells, where we can see noticeable characteristics, differences between horizontals and verticals, between different formations, and in the performance of the disposal capacity over time. So Howard Anderson, our reservoir engineer, has spent a great deal of time in gathering and verifying data as laid out in here to understand reservoir engineering characteristics. And particularly one thing of real interest is to estimate a proxy for reservoir size by calculating the ratio of the volume of fluids injected versus the change in reservoir pressure, meaning in simple terms that a big change in reservoir pressure injecting a small amount of fluids means that we've got a relatively small reservoir capacity, and it's not going to take too many of those fluids before we need to move on to the next wellbore. And just an example in map view of a little bit of Howard's work. So we see that we've got some horizontal injector wells down in the southwest here. They're more recent ones within the Montney fairways. You can see with the association with all the Montney horizontal wells drilled in the area. Some of the other Cadomin injectors, vertical wells, they're older wells. They're up here in the Boundary Lake area associated with the old Boundary Creek conventional oil reservoir, which of course is still being produced today and still producing a bunch of water that needs to be re-injected. So we're able to compare the performance of the Cadomin in two different areas. Now, obviously the Cadomin is quite different, buried more deeply to the southwest than it is to the northeast. A lot of different characteristics, but a lot of horizontals drilled in the southwest versus the northeast as well. So we've made some comparisons. They're not perfect, but they're indicative. We see much better horizontal injectivities than we see in vertical wells, a much lower decline of injectivity over time for horizontals versus verticals. And just a lot of other variability around here. In general terms, we can see that in many of these wells that the late or most recent injectivity is actually lower in both horizontal and vertical wells than in the early stages. But in other cases, this one here, for example, in the further south magenta dot, they're pretty equal over time. So there's a lot of things that we're finding out with our reservoir engineering analysis as well. So I'd like to sum up just by talking a little bit about some of our early findings. So obviously water disposal will continue to be important in the Northeast BC Montney Fairway, but we see over time that recycling and cooperative water management should greatly constrain the volumes that need to be disposed. Operators guided by the existing regulations that develop many best practices to guide their disposal strategies, but it would be great if we could collect a lot more hard data and make systematic comparisons of that information. Significant disposal capacity now is under development or developed in the major aquifers of the Peace River, Blue Sky, Cadomin, Baldonal, Halfway, and DeBolt. The Nikonas and Buick Creek, we've done a fair bit of mapping work on it, and it actually offers large capacity in terms of net porous reservoir space, but it hasn't been tested very much. Most of the Nikonas and Buick Creek injectors are actually jointly perforated with the Cadomin, so we haven't been able to isolate out their behaviors independent of the Cadomin. So that's an intriguing point to look at, because a great deal of the southern part of the Montney Fairway has a thick, relatively porous Nikonasan section. We've seen even just the hints so far of our early work that major structural elements will play a role in reservoir properties and their compartmentalization. The detailed analyses of reservoir engineering and geomechanics that we've accomplished so far have are starting to help us understand reservoir aquifer performance, but we do need to see more data that we hope to obtain, and work is in progress. In fact, the project team does have an arrangement with Geoscience BC to direct new lab work to address some of the data gaps. So thank you very much. If you've got some questions or discussion, I'd be pleased to undertake those right now. Thanks again.